Hello friends, welcome to our channel HTLT Electrical and Electronics Engineering. Today here I am going to discuss about earthing system part 6. Here it is Y axis, ER axis. ER means earth resistance and D means X axis, distance from electrode. Here it is the electrode driven in the ground. This is the X axis and this is the distance from the electrode. The chapter is resistance area of earth electrode. Let's start. During flow of fault current, the potential difference exists between 2 points on earth surface surrounding the earth electrode is called the resistance area of earth electrode. In figure above, how earth resistance is changed with distance from earth electrode is shown by graph. The earth resistance is increased with the increase of distance from earth electrode. Here it is increased. Earth resistance here is the y axis. It is increased here. So but here is the rate of increase of resistance is decreased with the increase of distance after a distance x is equal to 250 to 300 meter shown in figure. The rate of increase of resistance is 0. It is the distance 250 to 300 meter. After the rate of increase of resistance is 0. The rate of change of resistance surrounding the electrode is circular type. Here it is the electrode and this is the circular type shown in figure is called resistance area of electrode. Generally, after 30 meter, the rate of increase of resistance is negligible. Actually, the meaningful rate of increase remains within 10 meters surrounding the electrode. It is the here to here, it is the 10 meter. That is why the distance between two electrodes is kept 3 meters and the distance of earth electrode kept from foundation 2 meter. This is to prevent the overlap of resistance area. This is the resistance area. To prevent the overlapping of two electrodes resistance area, the two electrodes are kept 3 meters distance. Okay, next. Here is the measurement of earth resistance of electrode. This is done by earth tester megar. This is the earth tester megar. It has 4 point E1, P1, P2, E2. First sort the E1 and P1. Then this is connected to the electrodes whose resistance will be measured, and this is to first stack or spike, and this is the stack or spike. Second, this is connected from P2 and this is connected from E2. These are of 12 dia spike. The distance is 23 meter and this is the 23 meter. Connect the E1 and P1 terminals and then connect it to the electrode whose value will be measured. Then connect the P2 terminal to stack or spike which is driven in the ground vertically at a depth 0.30 meter. Again connect the E2 terminal to another stack or spike which is driven in the ground vertically at a depth 0.30 meter. Position the two stacks or spikes in the straight line with the main electrodes equidistance 23 meter shown in figure. Take the measured value from the earth tester megar, which is the measured value of the earth resistance of the electrode. Okay, next. Here is the approximate value of earth resistance. The earth resistance of single electrode in normal soil is not to be greater than 5 ohms. The earth resistance of single electrode in rocky soil is in between 8 ohm to 10 ohm. Maximum permissible value of earth resistance of EHT substation 0.5 ohm. Maximum permissible value of earth resistance of major substation 1 ohm. Maximum permissible value of earth resistance of small substation 2 ohm. Maximum value of earth resistance of other structures. Structure means it may be pole, it may be tower foot, uh, isolated structure is the resistance is between 8 ohms to 10 ohm. Maximum permissible value of earth resistance of residential building is 2 ohm. Maximum permissible value of earth continuity inside an installation is 1 ohm. Okay, next. Here is measurement of earth resistivity. Again the earth tester megar is applied from E1 is goes to spikes or stacks, and from P1 goes to stacks of spike, P2 from goes to another stacks of spike, from E2 goes to another stacks of spike. The four spikes or stack are kept in equidistance A. Okay, next. Measurement of earth resistivity. Earth resistivity is measured by earth tester megar. Connect 4 stacks or spikes to 4 different terminals E1, P1, P2, E2. Then 4 stacks or spikes are buried at minimum depth 0.3 meter at equidistance from each other in straight line shown in figure below. The minimum distance between stack or spike is 20 times stack or spike's depth. If the burial depth of stack or spike is 0.30 meter, then the length between stack or spike is 20 into 0.30 is equal to 6 meter. Here it is shown A is equal to 6 meter, A is equal to 6 meter, A is equal to 6 meter. If the value of the earth resistance shown R in the earth tester megar, then the value of resistivity rho is equal to 2 pi AR, or resistivity rho is equal to 2 pi 6 R. Take the reading at an interval of 45-degree angle 8 times circularly to get the average resistivity shown in the figure. Here it is the four spikes E1, P1, P2, E2. Then circularly the reading is taken for 8 times. This is 360 degree rotation. In 360-degree rotation, reading is taken. Then the average earth resistivity are obtained. Okay, next. Here it is shown the resistivity of different soil. Clay or soft, it is the mean value of the resistivity in ohm meter. For clay soft, this is 50 ohm meter. Clay sand 50 to 500 ohm meter. Clay compacted 100 to 200 ohm meter. Humus leaf mold 10 to 150 ohm meter. Peat turf 5 to 100 ohm meter. Marl 100 to 200 ohm meter. Soil chalky 100 to 300 ohm meter. Schist cell 50 to 300 ohm meter. Jurassic marl 30 to 40 ohm meter. Stony subsoil grass covered 300 to 500 ohm meter. Stony ground 1500 to 3000 ohm meter. Granite 1500 to 10,000 ohm meter. Granite modified 100 to 600 ohm meter. Limestone fissured 500 to 1000 ohm meter. Mica schist 800 ohm meter. Sandstone modified 100 to 600 ohm meter. Siliceous sand 200 to 300 ohm meter. Effect. Here is the effect of resistivity on corrosion. When the rho is greater than 100 ohm meter, then it is slightly corrosive. Rho is greater than 50 ohm meter but less than 100 ohm meter, then it is moderately corrosive. Rho is greater than 10 ohm meter but less than 50 ohm meter, it is corrosive. Rho is less than 10 ohm meter, then it is severe corrosive. Okay, next. Here is specification of GI strips. Description of GI strip: weight kg per meter, 20 mm into 3 mm, 0.5 kg per meter, 25 mm into 3 mm, 0.6 kg per meter, 25 into 6 mm, 1.2 kg per meter, 32 mm into 6 mm, 1.5 kg per meter, 40 mm into 6 mm, 1.9 kg per meter, 50 into 6 mm 2.4 kg per meter, 50 into 8 mm 3.14 kg per meter, 50 into 10 mm 4 kg per meter, 65 mm into 8 mm 4.082 kg per meter, 65 into 10 mm 5.10 kg per meter, 75 mm into 8 mm 4.71 kg per meter, 75 mm into 10 mm 5.89 kg per meter, 75 into 12 mm 7.065 kg per meter. Okay, next. Here is specification of GI wire in standard wire gauge. Description of GI wire SWG, and here it is weight kg per meter and area in square mm. 16 SWG, area 2.076 square mm, and weight kg per meter 0.021. And next 14 SWG 2.62 square mm and 0.027 square kg per meter. And next 12 SWG, area 3.24 square mm and weight 0.054 kg per meter. And next 10 SWG 5.48 area square mm and weight per kg per meter 0.0 0.067, and this is 8 SWG, 12.97 square mm and 0.131 kg per meter, and this is 6 SWG, and this is 18.33 square mm, and this is 0.192 kg per meter, and this is 4 SWG, 27.27 square mm, and this is 0.26 kg per meter. Okay, next. Here is specification of MS rods, description of MS rod, dia in mm and weight kg per meter. Here is 6 mm, 0.23 kg per meter, 8 mm, 0.4 kg per meter, 10 mm, 0.62 kg per meter, 12 mm, 0.9 kg per meter, 16 mm, 1.6 kg per meter, 20 mm, 2.5 kg per meter, 22 mm, 2.98 kg per meter, 25 mm, 3.9 kg per meter, 30 mm, 5.5 kg per meter, 32 mm, 6.312 kg per meter, 35 mm, 7.551 kg per meter, 40 mm, 9.9 kg per meter. Okay, next. Here it is, GI pipe electrodes specification, description of GI pipe electrodes, dia in mm into length, 40 mm dia into 2 meter length, 40 mm dia 2.5 meter length, 40 mm dia into 3 meter length, 40 mm dia 4 meter length, 50 mm dia 2 meter length, and 50 mm dia into 2.5 meter length, 50 mm dia and 3 meter length, 50 mm dia 4 meter length. Plate electrode specification, 600 mm into 600 mm into 6 mm thick GI earth plate provided with 20 mm dia, 2.85 meter long GI pipe for watering, and for copper 600 mm into 600 mm into 3 mm thick copper earth plate provided with 20 mm dia, 2.85 meter long GI pipe for watering. Okay, next. Specification for chemical earth electrode. Here it is pipe OD, outer diameter, and this is the flat size, and this is the length, and earthing compound in kg. Pipe OD 60 mm, flat size 50 mm into 6 mm, length 2 meter, earthing compound required 25 kg. 60 mm, flat size 50 mm into 6 mm, length 3 meter, and earthing compound required 50 kg. 75 mm outer diameter of pipe, flat size 50 mm into 6 mm, length 2 meter, earthing compound required 25 kg. Again 75 mm outer diameter of pipe, and flat 50 mm into 6 mm, length 3 meter, and the earthing compound required is 50 kg. And again pipe outer diameter 50 mm, flat size 40 mm into 6 mm, and length 2 meter, and earthing compound 25 kg. And again pipe outer diameter 50 mm, flat size 40 mm into 6 mm, length 3 meter, and earthing compound required 50 kg. Here flat means the at the top of the earth electrode, the flat where the connection is done, this is called the flat. Okay, next. Here is the application of protective earthing strip. For example, some example here is provided. Number 1, HT switch gear and structure, cable trays and fence, earthing strips 50 into 6 mm GI. Like for lightning arresters, second 25 mm into 3 mm copper. For PLC panel, PLC means programming logic control panel, 25 mm into 3 mm copper strip. And next, DG and transformer neutral 50 mm into 6 mm copper. Transformer body 50 mm into 6 mm GI. Lighting and local panel 25 mm into 6 mm GI. Control and relay panel 25 into 6 mm GI. Distribution board 25 mm into 6 mm GI. Motor up to 5.5 kilowatt, 4 square mm GI wire, and motor 5.5 kilowatt to 55 kilowatt, 25 into 6 mm GI. Motor above 55 kilowatt, 50 mm into 6 mm GI. Thank you for watching the video. If you think the video is useful to you, then please share it to your friends and please subscribe our channel. Okay, bye. See you in the next chapter. I am going to discuss about in the next chapter about substation busbar system. Okay, bye. See you in the next chapter.